In this lesson, we shall focus on the sine rule, the cosine rule, and the area rule. Okay, now we start by looking at question 7. In the diagram, the angle P is 67 degrees, PQ is 3 centimeters, and PR is 9,2 centimeters. Determine the length of QR. Right, and so to find the length of QR, we proceed as follows. Right, we use what you call the cosine. Right, so it is something called the cosine rule. So we first note that opposite the angle P, it's lowercase p, opposite the angle R, it's lowercase r, and this is lowercase q, so that we have p squared is equal to q squared plus r squared minus 2qr cosine of the angle opposite, and opposite the side P is the angle capital letter P there. Okay, right. And upon careful examination, we want to find the length of QR, and that is lowercase p there. So which means that we have p squared equals the q squared, which is 9,2. You square that, and the r is 3 squared. 9.23 here, cosine 67 degrees. Right, and we continue therefore to find these results, and if we use our calculator here, we actually able to get the square root of this, square root of the left, the square root of the right. Now we get only the positive square root. Why? Because we are dealing with the length of the side. We are determining the dimension of a shape, of a geometrical formation, and if we do so, we need to note that we have their a positive length. Okay, right, and if we use our calculator here to find the square root of this result, it is actually 8,49 centimeters. So, and now because it is our length P there, which means that hence QR, which is obviously P, is actually therefore equal to 8,49 centimeters. Okay, this is called the cosine rule. For this particular triangle, the cosine rule, or what you call the law of cosines. Okay, the law of cosines. What does it say? So we can be interested in finding the length of the side P. So we write therefore P squared equals Q squared plus R squared minus 2QR cosine P. Okay, now I can write it in a different color, blue. We can be interested in finding the length of the side lowercase q, and q squared is going to be equal to p squared. P squared plus r squared minus 2 pr cosine q. We can be interested in finding r, so that r squared is p squared plus q squared minus 2 pq. Okay, so if we want to find r, we start with p squared, q squared minus 2pq cosine r. And this is exactly what then we have here. So there, what we call the cosine rule or law of cosines can be therefore broken down and can be stated in these particular forms. From these forms, we can be in a position to solve and make something the subject of the equation there. We proceed right now. So we found the length of QR, and we can see therefore that QR is 8,49 centimeters, and out of the 3 marks there, we are done. And we proceed to look at the next question there. Okay, right. So, next question. Right, so now in the diagram below, we have DCB, the angle DCB. The angle DCB equals the size alpha, and we have that AC is H. So if we have that AC equals H units and ACB is theta, we have that ACB equals theta, and one determine the size of ACD, the angle ACD, right? So the angle ACD equals what? Okay, remember the angle ACD in terms of theta and alpha. Right. Sorry. Now we want to find the angle AC, this angle here. And now we know that the entire angle is theta. And if we subtract alpha from it, you'll get the angle the examiner wants. So, and that would therefore mean the following. Right. So it therefore means that the angle ACD is equal to theta minus alpha. Is theta minus alpha? Because if you have theta minus alpha, then that is what we want. That is what we want. So the angle ACD is theta minus alpha. The angle ACD equals theta minus alpha. ACD equals theta minus alpha, and that is what we have. So it is exactly theta minus alpha there. Okay, good. Next question. We need to prove that. So yeah, the information above remains the same. And also we know that this one is theta minus alpha, which is the size of this angle there. And we need to prove that AD equals this. AD equals exactly that. So at this point, we need to do the following. We need to do the following. Right, so if we want to prove this, want to prove exactly this. So want to prove that AD is the following. Right, so we proceed as follows. Right, so we proceed as follows. So we can decide to work in a specified triangle. So if we need the AD here, we can decide, okay, we have AD divided by the sine of this particular angle would therefore be, so there is h, so you have h divided by the sine of the angle opposite, and therefore the angle opposite here is what? Is this angle here, and this angle D1 is an exterior angle of this particular triangle here. So we go back to grade 10 a little bit. And this is what we have. So we have that the angle D1 is equal to 90 degrees plus alpha. Exterior angle of triangle is the sum of the interior opposite angles. So this is the exterior angle of triangle. The exterior angle of triangle equals sum of interior opposite angles. So this angle here is 90 degrees plus alpha. 90 degrees plus alpha. So that now we then say in triangle, tell the examiner triangle choose to work in. So you're going to work in triangle ACD. Right, in triangle ACD, what we have here is the following. Right, so we want to find AD, so we're going to say first, things first. AD over the sine of the angle opposite theta minus alpha. AD, it's actually equal to H over the sine of 90 degrees plus alpha. Okay, so now what is this? It's AD divided by the sine of theta minus alpha. And it is H. This is exactly H divided by, now if you say 90 degrees plus alpha, that is in the second quadrant in view of the cast diagram. Okay, so if this is 0, 90 degrees, 180 degrees, 270 degrees, 360 degrees, so 90 degrees plus alpha. 90 degrees plus alpha is an angle in the second quadrant in which the sine is positive, but it changes to its co-function. Now, the co-function uses the notion of what we call the Coco rule. And the Coco rule switches and allows us to say if you have the cosine function, it was going to change to to the sine function, and the reverse is true. And this happens at 90 degrees and 270 degrees. So, which means that in the second quadrant, the sine is positive, but it changes to its co-function, giving us the cosine of alpha there. And therefore, we perform cross multiplication. And if we cross multiply, it means that AD equals exactly H, the sine of the angle theta minus alpha divided by cosine alpha. This is called the sine rule. This is called the trigonometric. It's called the trigonometric sine rule. If you want to call it the sine rule, we call it the law of sines. What does this law actually say? Sine A over A equals sine B over B equals sine C over C. Okay, this can be stated this way, or you can state it as A over sine A is B over sine B equals C over sine C. And this, guys, works in our beloved triangle, which is the A, B, C, A, B, C. So opposite the vertex B is lowercase b, opposite the vertex A is lowercase a, and opposite the vertex C is lowercase c there. And now we have used the law of sines, or what we call the sine rule, to prove the result in question 7.2.2 there. And we continue to establish even much more results. We establish more results there as follows. We establish more results there as follows. Next question. Right, question 7, the diagram below, we have DCB equals alpha. So if you have DCB equals alpha, then it is indeed alpha, and we have the rest of those. And obviously, we've seen that at this point here, this one is alpha minus theta. And then now we want to determine the length of AD. Right, so determine the length of AD if H is actually 17 units. So H is 17 units, theta and alpha that. Okay, we need to recall what we got from the previous question. We got that AD is H, the sine of theta minus alpha divided by cosine alpha. So we know that AD equals H, the sine of theta minus alpha divided by cosine alpha. 80 is H. It's 17 the sine. What is theta? 58 degrees minus alpha. Alpha is 23 degrees. Okay, what we're doing here is basically substitution, and this is divided by the cosine of alpha, and alpha is 23 degrees. Okay, you can still do without the parentheses in the denominator. So you can write up here exactly 23 degrees, meaning that AD itself is 17 the sine of the 20, rather the 58 minus 23 degrees, which is actually going to give us what we want. And what then we need here is the following. Right, so 7.2.3, so this is the sine of 25 degrees divided by the cosine of 23 degrees. And this means that AD itself is approximately 10,59 units. 10,59 units. So we have 10,59 units. Right, so this is what we have. So it is exactly that. So we've got that because we're determining the length of AD, and we found that the length of AD is actually 10,59 units. And we obviously use the consequence of the sine rule here, which we were able to prove in the previous question. We're able to apply. We applied the sine rule in the previous question to establish this result. So it is the sine rule we used, or what you call the law of sines. The law of sines. Next question. In the diagram below, we have DCB equals alpha. DCB equals alpha, this alpha here, and we have the rest of this. Okay, we need to calculate the area. So here we're going to use what we call the area rule. Right, so the area rule is very clear. Let's state the area rule for somebody who needs to know. Okay, if this is A and this is B and this is C, this is B, this is C, and this is A, so that we have the area of triangle ABC. Okay, the area of this triangle can be stated in three ways because there are three vertices. So we can then say it's half BC sine A, half the product of the lengths of the adjacent sides by the sine of the included angle, or we have half here AC the sine of B, or this is exactly half AB the sine of C. Okay, so we have this. We have this. We have this. So now to look at the 7.2.4, now we want to find the area here. Right, so to find the area of the triangle ADC, ADC, how do we therefore find the area of this particular triangle? So to find the area of this particular triangle, you already have a couple of the lengths that have been given, but also we have been able to find AD. What did you find AD to be? We found AD to be 10,59. AD is 10,59 units. So AD is 10,59 units. And then H is 17 units. And yeah, H is 17 units. And also alpha is 23 and theta is 58. So H is 17 units. Right, so H is actually 17 units. Right, so theta is 58 degrees. Theta is 58 degrees and alpha is 23 degrees. Alpha is 23 degrees. So we want to therefore be in a position to determine what we desire, most importantly. So we want to find the area of the triangle ADC there. Let us find that area there. And so to find the area of the triangle ADC, we proceed as follows. So area. Right, so we have that area of triangle ADC is half AD, AC, the sine of A. Half AD, AC times the sine of the angle A. Okay, because if you already know the angles here, for example, you already know that this angle here is of a given size. Okay, we already know that the rest of this angle is 23 and the rest of this angle is 90 degrees. So we would require that if this is 58, so this one is going to be exactly 32 degrees because 50 plus 30 is 80, 90, and therefore 90 plus 90 is 180. So area of triangle ADC. AD 10,59. AC 17 because AC is H and H is 17 units. And H is exactly 17 units. We multiply that by the trigonometric sine of 32 degrees. Using a calculator, this is 1/2. Using a calculator, we get 47,70 units squared, which is 47,70. You can write square units. You can write square units. So that this is the area of triangle ADC. Area of triangle ADC. Take a look at this and pay attention to this. Take a look at these. So yeah, we have the area of triangle ADC is that one. And we found the area to be 47,70 square units. And we proceed to solve the next question. Question 8. The diagram below shows a cone. Here is a lovely cone, a wonderful cone with a perpendicular height h centimeters, a radius r centimeters, and a slant height of 13 centimeters. We have a slant height of 13 centimeters there. Show that the volume of the cone is given by this guy, given by this particular equation. So, right, to find the volume of the cone, there are a couple of things that remain very important. But first things first, we want to solve question 8.1. And in question 8.1, proceed as follows. Right, let's take a look at what we need to do here. First and foremost, we're going to use our Pythagoras theorem because we have a lovely triangle here. So Pythagoras theorem says that the square on the hypotenuse, because this is a right-angled triangle, in view of the cross-sectional examination. So we have that 13 squared equals r squared plus h squared. And what motivates this is Pythagoras. Pythagoras theorem. Is Pythagoras theorem, okay? And then now we want to make, we're going to make here r squared the subject of the formula. So that r squared is equal to 13 squared, 169 minus h squared. Okay, from Pythagoras, we're able to get 169 minus h squared. Okay, the volume of a cone is basic, but yeah, it is area of base is 1/3 area of base by height. So it's 1/3 area of base. 1/3 area of base by perpendicular height. Now, what is this? Is 1/3 the area of the base. Okay, the base is a circle and the height is h given by the examiner. The volume, 1/3. Pi, the radius. Okay, the r squared is exactly what we got above. It's 169. And obviously, I mean, it brings about the justification on why we did what we did. 169 minus h squared. Put h here. So which means this is actually the same as pi. We can write the things properly. Let's order our numbers and coefficients properly so that we have 169 pi h minus pi h cubed. Okay, because h squared by h is h cubed. You divide everything by 3. We divide everything by 3. Okay, now take note of this because this is exactly the formula here. So we're to show that the volume of the cone is given by V equals 169 pi h minus pi h cubed. You divide everything by 3, and that is what we have. And this is what we have. And this is exactly the result. And we have got the results here. And we have solved this particular problem step by step. So yeah, we advance to the next question step by step. Right, if h is 12, determine the total surface area. The total surface area of the cone. Okay, now first and foremost, okay, we have knowledge of the formula for the total surface area of a cone. So we say that total surface area. Total surface area is pi r squared plus pi rs. Okay. Now, this is the total surface area. Total surface area. Okay, so the total surface area, therefore, can be seen as the pi r squared. But now I want us to pay particular attention to what is needed. Okay, so the r, what is the r? We just need to calculate the r so that we can plug that in there. But also we need to calculate the slant height as well. But okay, that one is obviously already known, the slant height there. So what then we need to do, so there is obviously our lovely friend, our total surface area. Okay, for the cone. Right, so we continue then to then say the following. So now we need to say R. Right, so I mean we got H is 12. Okay, now if H is 12, what then do we say? So H is 12, then we have the R we can get using Pythagoras theorem. 13 squared is 12 squared plus R squared, and the reason for this is our old friend Pythagoras. 169 minus 144. Okay. 169, 144 is 25. R squared. 5 is R. Okay, now R is 5. R is 5, and obviously the unit of measurement is the centimeter, and therefore, but we also have the slant height in 13 centimeters. Total surface area. Which is pi. Okay, the radius is 5, which is square pi. The radius is 5. The slant height is 13. And we get what if there is needed here. So this is actually 25 plus 5 by 13, and this would give us exactly 90 pi. And we have that this is approximately 282,74 square centimeters. Okay, so we have exactly this there. We have exactly that. So the total surface area of the cone is exactly 282,74 square centimeters. And we're done with this question. Right, so we have solved these particular questions on the sine, cosine, and area rule. These questions were taken from the grade 11 paper written in 2018 November. Right, it was a national paper. But thanks everybody for your time and attention, and a very, very goodbye to you.